Whew, another section done. And we covered sorting, specifically sorting algorithm in this section. Most of the time, when talking about sorting algorithms, we're going to be talking about O of n log n. We learned that there's a ton of sorting algorithms, and we covered the main ones that get used more often. If you're really excited about the topic and you find this interesting, then, well, good for you. You're one of few. I encourage you to search different sorting algorithms. But to review, quicksort you want to use when your average case performance matters more than the worst case performance. Because quicksort allows us to sort in O(n) log n, but in worst case, in O of n squared. Merge sort, on the other hand, is great because it's always O of n log n. It's also stable, which means that it always gives the same results in order if two items are the same. Although the space complexity is a little bit higher than quicksort, it's definitely a useful sort. We also talked about insertion sort, selection sort, and bubble sort. Those are fun when you're doing something quick and dirty and you want to just experiment around with sorting. But in real life, you're not going to use them. And most likely in real life, you're using the framework or languages or libraries sorting algorithm. Their advantage is that they're fairly easy to implement in code. And during the interview, you might say something like this in those rare cases that they ask you to implement a sorting algorithm. You'll say, well, because we have a time constraint, I'd like to use something naive and not efficient like bubble sort, which is slow in real life, instead of implementing something like merge sort, if it's okay with you, because we can assume that merge sort is something that we can implement with a library or fairly easily with documentation. Or you can say something like, we can just use merge sort to divide and conquer the code to make it more efficient. And this way, you show the interviewer that, yes, you can implement sorting like bubble sort, but you also know about things like merge sort to make it more efficient without having to actually implement it. So by the end of this all, I hope you now understand the trade-offs, where you can look at sorting algorithms and decide based on their speed, stability, and their readability, whether the input is already sorted or nearly sorted. How large is the input? You can make the right decision on sorting. I'll see you in the next one. Bye-bye.